Hello, scientists. For today's video, this week's video, I'm going to be connecting some stuff that we have been learning about so far this semester, our states of matter stuff, to a couple of concepts we're going to learn about at the end of this week and for the next couple of weeks, chemical reactions. Okay, so just to remind you, just like I did for the last video, I am going to give you 3 secret words instead of 4 this time. It's going to be 3. And don't forget to write them down and submit your 3 secret words that you hear in this video along with your 7-sentence summary that you're typing up after you do the reading for this assignment. Okay, so this is how you submit it. A couple of people did not do it correctly last time, but most of you did. So here is your 7-sentence summary. Obviously, you're going to summarize what you read in the reading. And then underneath that, you can list the secret words, with separated by a comma. Okay, so that's how you're going to submit it. And the first secret word is going to be candy. C-A-N-D-Y, candy. All right. So what I wanted to talk to you about in this video is how we've been talking about atoms, right? I kind of talked about molecules a little bit, and we did look at the water molecule in the gizmos, phase changes of water, that assignment that we did together in class. But if you look at this thing, this right here is a molecule. It's the water molecule, H2O, right? Many of us call it by its chemical formula H2O. And what H2O means is that there are 2 hydrogens and 1 oxygen, and they are stuck together to make this water molecule. Okay, but if you were to separate these into individual pieces, each one would be an atom. Okay, so there's one H atom, hydrogen, another hydrogen atom here, and then an oxygen atom. So these 3 atoms are stuck together by this force called a bond. All right. And what's interesting is when these atoms are separated, when they're not stuck together, if they were separate, they would be like completely different. This is obviously a molecule of water. But if you had hydrogen by itself, it would be a gas, and oxygen by itself, as you know, is a gas too. So that's important to know. And in class this week, we're going to be talking about other examples of molecules. This one, for example, is the caffeine molecule. And you can see it's a more complicated molecule than the water molecule, but it's still a molecule because it's 2 or more atoms that are connected to create a new structure. Okay, so check this out. There are some carbon atoms here connected to some nitrogen, connected to oxygens, connected to CH3. Okay, all of it's over here, labeled in this key. And so what I need you to understand is that atoms by themselves, they can stick together to form molecules, which are more complex structures because it's more than one atom combined, okay? And actually, this is very important to know because you and I were made of these really, really long, big, giant molecules that have all of these atoms. Look at this thing. This is DNA, right? This DNA molecule by itself has a ton of atoms, like I don't know how many tons of atoms. And of course, they're teeny tiny inside of our body, inside of our cells. That's what our cells are made of. All of these things. So carbohydrates are things like sugars. Okay, when we talk about sugars, that's why fruits taste so sweet inside of your mouth, right? Because of the sugars. Sugars are molecules that are these super long chains of all of these like hundreds of atoms that are all connected together in a pattern. Lipids, which are fats, proteins, which make up your hair and nails and are inside of your muscles, and then DNA. So you and I were made of these atoms and molecules, and these are very important for our daily life. So we're going to talk about matter this week, and matter, everything that takes up space and has a mass is made of atoms and molecules. And like we learned, solids, liquids, and gases are molecules that have a certain amount of energy. Okay, so solid objects don't have much energy. Okay, they're not hot usually. Let's say we're talking about the water molecule. Ice has to be a certain temperature, 0 degrees Celsius or below, in order to be solid and stay solid. And that's because it doesn't have much energy or heat inside of each molecule, right? We learned this. If you add some heat energy, then the solid ice is going to behave differently. The water molecules are going to start vibrating a little faster, start moving around. Maybe the solid structure of the ice is going to break up with even more heat, and it'll become water, liquid water. And then if you add even more heat, that's going to cause these water molecules to move around a little bit faster and faster until it becomes a gas or a vapor. Okay, so this is all important for you to know, because what we're going to learn about next is about chemical reactions. And chemical reactions, as you can see in this cool video here, a chemical reaction means that you have something that you start with, okay? A substance, maybe you combine two substances together, and it goes through some sort of chemical reaction that changes that original substance into something completely different. Okay, so fun to watch. And I'm going to use this example right here of photosynthesis. Maybe you've heard of it. Photosynthesis is something that plants do. And if plants didn't do it, we would all be dead, because plants do photosynthesis and create oxygen, which we need to breathe, and sugars, which we need to eat. If you eat any kind of plants or meat, if you eat beef or chicken or pork, those animals ate plants so that they could make meat for you to eat. So this is very important for us to know and understand. And this is what plants do, photosynthesis. What they do is they breathe in carbon dioxide. Okay, look at this carbon dioxide molecule. One big carbon stuck to two oxygens, similar to H2O, but the angle of the atom connections are a little different. This one is H2O, which we talked about. So plants need water, which they suck in through their roots. They breathe in carbon dioxide through their leaves, and they use energy from the sunlight, or, as you know from our growing plants gizmos, it could be artificial light, like a lamp. And they use these things to create this crazy big chunky molecule called glucose, which is sugar, and oxygen. Okay, and this is a chemical reaction. And so what happens is plants, they combine inside of their bodies, inside of their cells, they combine water molecules and carbon dioxide molecules to make sugar. They just make it from scratch. And then some of the oxygens from the water molecule and from this carbon dioxide combine to become oxygen, which plants release through their leaves. Okay, so that's what a chemical reaction is. We have things that we're starting with before the chemical reaction happens, and then after the chemical reaction happens, that's what this arrow indicates, that a chemical reaction has taken place. Afterwards, what you end up with is completely different from what you started with, but everything over here was made of the stuff that was on this side. It was just rearranged, like as if you had like a Lego, car, and then you took all the Lego pieces apart, and then you made a Lego shark. Okay, it's a completely new thing, but they're all made of the same pieces, just rearranged. Okay, my last example for you, our second secret word is going to be panda, like the panda bear that eats bamboo, Panda. All right, my last example for you, and to connect it to health from last semester, and to show you also why this is so important for us to know, is that it's happening in our bodies every day. So what happens when we eat food, for example, is you eat, let's say, some broccoli. Okay, that broccoli has iron in it, it has calcium in it, it has sugars in it, it's made of all of these atoms and molecules. And when you start chewing it in your mouth, your saliva is breaking it down, and you swallow it. It goes into your stomach organ right here. The stomach acids come up. It breaks it down even further. And then it sends that mush of all the broken down, pieces of broccoli and all the other food you ate. It sends it into your small intestine first. Okay, you should have learned about this last semester. where your small intestine, now that it's broken into smaller pieces, and how small are we talking? I'm talking about the size of this molecule right here, right? The carbohydrates, for example, it was in the broccoli, but your stomach acid and all these other chemicals in your stomach broke it down into pieces that are this size. So you have one, big old molecule, and then it's small enough for your small intestine right here to absorb those molecules that your body needs, the sugar molecules that your body needs. It absorbs it and then puts it where? Do you remember? It takes it out of the small intestine and puts it into your bloodstream. And your blood, remember, is like the freeway. It takes all of that sugar or vitamins, minerals, calcium, iron, all that good stuff to all the rest of your body, using the veins and arteries that your blood flows through. Okay, so these concepts that we learned before are totally connected to what we're learning now, because everything is made of atoms and molecules. And when they go through a chemical reaction, just to review, they start off as one thing, but they go through a chemical reaction and they end up as something completely different. Okay, so that's what you're reading about in your textbook reading homework. And that's what we'll be talking about at the end of this week and into next week for the next few weeks. Alrighty, the third the third secret word is firework. Okay, like the 4th of July fireworks. Firework. All right, thank you, everybody. See you in school.